A sphere whose volume is increasing at a rate of 3 pi cubic inches per hour, and we want to find at what rate is the diameter increasing when the radius is 4 inches. The equation for the volume of a sphere is 4/3 pi r cubed. Now this equation relates the radius to volume, and we're looking for the diameter. We know the diameter is twice the length of the radius, so that makes that the radius is half the diameter, which we can go ahead and take this relationship and plug into our equation to get the volume and relate it to the diameter. Now to reduce this down, the first step is to go ahead and cube both terms in the parentheses, so that's the d and the 2. So 2 cubed is 8. Now 4 divided by 8 is just 1/2, so we can reduce this down to 1/3 pi times d cubed over 2. And so the 3 times 2 gives us 6. So this gives us d cubed divided by 6 times pi is our equation for the volume. Now that we have our equation relating the volume and the diameter, we can take the derivative of this equation because we're looking for the change. So the derivative of volume is just dv over dt, and that equals, now pi is a constant, so we can just ignore it for now. We'll just multiply it at the end. So we have to use the power rule here to find the derivative of d. So we bring the 3 forward and down, making it 3 times d, and then subtract 1 from the power, giving us the power 2. And then the 3 divided by 6 reduces down to 1/2, giving us d squared over 2 times pi. And then we do have to multiply this by the change in diameter with respect to time, because again, we have to use the chain rule here. Now we can go ahead and plug our numbers in. So our change in volume with respect to time is 3 pi. Our diameter, we don't know what it is yet, but we do know the radius is 4, so we can plug that in for our equation that relates diameter and radius. So 2 times 4 is 8, so our diameter here is 8. And so we're trying to find the change in diameter with respect to time. We can go ahead and cancel out the pi's on both sides of the equation. And then we can multiply both sides of the equation by 2 to cancel that out. That gives us 6 equals 8 squared times our change in diameter with respect to time. So 8 squared is 64. So we divide both sides by 64. And that gives us that the change in diameter with respect to time is 6 divided by 64, or 3/32.